So thanks for the kind introduction. And when we're looking into supply chains or any topic, the first question is always, why should I care? Should I put time and why should I put money into this? And there have been a few incidents lately that have shown very wildly why this is a relevant topic. For example, there has been the Log4Shell vulnerability, which was essentially a vulnerability in a library that was used by almost every Java program in the world. So classical supply chain security, you're depending on someone else for a very minor functionality. Your customers are not paying you to do logging. Your customers are paying you to do financial transactions. But somewhere down the line, you're using logging. And a vulnerability inside the logging infrastructure suddenly allows people to take over that entire Java instance, inherit all the privileges of that Java instance, and then conduct all the activities that this Java instance is privileged to do. So if this is an online banking, the attacker suddenly becomes the online banking and has all the privileges of the process that runs the online banking. Classical supply chain topic. If you're a software developer, for example, you're the company that creates the online banking apps for the banks. The federal government is actually looking into liability clauses for software developers. So this is something that we already know from the analog world, but this is supposed to also enter the digital world now, that you can be held liable directly for what you're supplying to other people. Or if we turn around this whole thing once again, and look into data protection issues, then we can see that there are fines for GDPR violations. And in the end, it doesn't matter whether this was something that the bank did wrong or where the bank used a software that was just not up to the state of the art. The data breach happened, and the respective authorities fined the company that was responsible for processing the data. So we're talking about banking institutions, we're talking about private equity institutions, we're talking about, for example, big airlines, and this is money. This is 508 million euros in that case. This is 67 million euros. So this is nothing that you just ignore and just pay and be fine with it. And it doesn't matter if this was because your used software was broken or whether you actually yourself did it wrong. The big question is always, whose problem is it? If we look at this landscape, you have the end user. It interacts with something that is hosted by some operator. For example, some company that you have a contract with so that they run your, let's say, online banking for you. There is some regulator that oversees you as a bank, but still you kind of trust that operator. So if something falls down on that operator, operational supply chain, it's your problem. You get software from a development company. If something breaks down in the end, well, it's your problem. Now, the big question here is, how can we actually take responsibility for the things that we are responsible for? Because we have the distinction of who can look into how the hosting is done, how the development process is done, and who is actually responsible for the outcomes of the software that is then used. If we look into the development company, they can apply, for example, a secure software development lifecycle. They can apply secure coding practices. They can look into their dependency management. But they are not the ones in the end who are facing kind of the outside world. And as a service provider, you have all these responsibilities. You have the reputation risk. Nobody will tell you nobody will write in the newspaper that the development company XYZ did something wrong when data is lost at a specific bank. They will always write data was lost at the bank. Because it's your responsibility to get that right in the end. But how can you do that? If you look at the development company, they have the code, they have the internal guidelines, they have the test reports, they have the design documents. Of course, you can now say, as part of my contract, I asked them to hand all of that over to me. But that means that you're sitting on their development process. That means that you have to check all, let's say in an agile design, all the design decisions that they are making for each sprint, for each iteration. Now, is that feasible or not? If you want to look at the source code, do a code review. that is a lot of effort. So usually the code review means that you're spending €1 per line of code, roughly. If you're saying you're conducting pen tests, well, that is feasible. You then have the external view on the product that you have. And for fixing, you have to discuss with the provider, because your pen tester might find something, say it's critical. Your software development company might say, well, this is not critical. This was just due to the test environment. So you have a very different view on what you're actually doing than the company that is building the stuff for you. And in a traditional way, where you just have where you just say, these are my requirements, then all you get to define are those requirements. Of course, there can be mandatory coding guidelines, there can be security requirements, and so on. But what you get back usually is the binary code. So does that binary code actually match the security requirements that I had in the first place? In that interface, you don't really have a good chance to check that. Or you tell them, give me your source code. Usually they will charge you more because they develop apps for multiple banks. So if they give out their intellectual property, their source code, for example, you're in a different game, usually also cost-wise. On the other hand, if you say, I don't care what you're doing, just tell me that you have references so that you know what you're doing, your people have been trained and so on, then it's still kind of a relaxed trust model. You still have to trust them that the formal qualification is also properly applied and not, for example, left out due to budget or time restrictions, and that people can actually live up to their qualifications. And of course, you still have to check the qualifications. So the problem is that in the end that you're liable for something that you have very little control over. And this is the problem of information versus responsibility here. If we look at how security scanning can help here, the shared asset that you have with your service provider is the software. If you have a development company that creates the app for you, then they give you the software. The software is what they work at. So this is the shared view that you have at the very minimum. There is no way they can develop something for you without giving it to you in the end. So why wouldn't it be a great way to look at this artifact? So you have the side of the software developer where they write the source code, they compile it, and then there is some artifact which is transferred to you and that you maybe transfer on towards an operator. Now, if we take that asset and if we scan this binary, then it's not only scan what you execute, because we definitely know that this is what gets into operation afterwards, and not I have source code here and I don't know whether this is the right version that is also used in my data center in the end. And it's something that you always have. And the idea here that we're looking into in our research is, how can we take that binary file that gets executed later on and scan this binary? So kind of the binary gets into production, the binary gets into the scanner, and the scanner tells you about functional code quality. Was this done well in an engineering perspective, but also security vulnerabilities? Note that we're not looking at the code here. We're looking really at the final binary. And this can then run in parallel to whatever unit tests or integration tests the provider does. And this also fits well into an agile development process. If you're, for example, looking into, you give them code link guidelines, and they first define the requirements, conduct peer reviews while programming, conduct unit tests, conduct integration tests, and this is kind of one 2 week sprint. And then they go on with the next items from their backlog, conduct a sprint again. Then what we're adding here is the security in every step. So from the requirements, there are security requirements derived. Peer reviews, what you can do is, as a good development company, you have some people that at least know when there is, when a critical function is implemented. We call them security evangelists. They're not really security experts, but they're good enough to know when they should ask someone. So they are kind of the team members on the same level that can escalate topics, or that can integrate security into a normal development team without requiring kind of a security expert on every team. And here on the right side, this unit testing and integration testing, this is where we bring in the scanners. And this is also where we have the mapping to this shared artifact that you have with the software developers. So you cannot really look into this left side. So security requirements you can try to define from the outside, maybe, but how they are actually integrated into the development lifecycle, you have little control over. Security evangelists or security trainings, whether the company does that, how well they do that, that is hard to check. But on the right side, when it comes to testing, this is something that you can do, because the binary is what you actually see here. And this is also that model of taking the final artifact, and you have that that loop back to the original issue definition. Because if you define, or if you find a quality issue, then this becomes a task for the next iteration, fix that quality issue. If you find a security vulnerability, then it's a make or break decision. Then you can say, this needs to be fixed in the next revision, or we cannot go online with this version. And this is also visible to the outside world, because you see the sprint artifact. You can do the same check. You can also apply a scan on this artifact and then engage in a discussion with a provider on whether this can be fixed later on, or whether this is actually breaking the deployment. And what we're arguing here for is use security scanning as a part of the normal functional testing, but in the interface between supplier and user. And it's actually a lightweight addition in comparison to pen testing, because there is no 2 weeks that it takes to conduct a pen test. This is something that a scanner can do in like 15 minutes. And then you can see, are we getting constantly fewer issues? Are we getting more issues? Does the provider adequately respond to the issues that are raised by the scanner? And if you're looking at those reports in the end, you can also look at indirectly at their processes. How do they deal with these reports? Do they just mark everything as fixed, or do they actually change the code before it's fixed and the scanner confirms the fix? And there is also the possibility to not even run that scan on your own. You can also say, I request the development company to give me not only the artifact, but also the scan report from a tool that I trust. In that case, you mark this as part of a certification process that your contractor also has to do for you, and it's verifiable. You can also say, I run the test again if I don't trust them, or I take the scan result and I just trust the tool. And this can also serve as an input for the pen tester. If you say, I still have to do some pen tests, for example, because I'm in a regulated industry and I need an IS web check, for example. If the pen tester knows the scanner results, he knows what the critical issues are that need to be looked into. Just one more case for why we're looking into binaries so much. If we are looking at binaries, we don't care how this binary came about. So how the development pipeline worked, which external libraries they integrated. In the end, it's one executable or a bunch of executables. And we also get this kind of previous stages of the supply chain in order. We don't care if they use log4j. In the end, it's just one big system. And we're looking at that final system, no matter how it was composed. So what you run on your computer, the final binary, that is always right. And we don't care about how this binary came to be. Yes?
We need to kind of...
Yes, I'm speeding up. So one of the last things to mention here is we're currently conducting a study where we're looking into how do pen testers relate to automated tools, because pen testers, they have their intuition, they have their expertise, whereas tools have, well, what was coded into them. This is an active research area, but what we found is that tools actually can supplement pen tests very well. For example, in purchasing a new product as to what is the general security level of that product, or updates, are we getting better, are we getting worse in terms of security, helping the pen testers find the critical positions. And as part of our research, we're also building such a tool, and this is the WUSC scanner that Ute has already mentioned. And with that, I'm already at the end of the presentation. So thank you